Welcome to all. I am Assistant Professor Kutte Akshada from SND Engineering College and Research Center, Yeola. Today's topic is Cathodic and Anodic Protection in Corrosion. First, Cathodic Protection. Definition of Cathodic Protection: the reduction or prevention of corrosion by making metallic structure as cathode in the electrolytic cell. It's called cathodic protection. Since there will not be any cathodic area on the metal, corrosion does not occur. There are two methods of applying cathodic protection to metallic structure. First, scarificial anodic protection, that is galvanic protection. Second, impressed current cathodic protection. First, scarificial anodic protection method. In this method, metallic structure is connected to more anodic metal. Hence, the corrosion is concentrated at the active metal only, and the active metal gets corroded slowly. The parent structure is thus protected the more active metal, so employ is called sacrificial anode. Sacrificial anode are commonly as magnesium, zinc, aluminium and their alloys. These are protection of underground pipeline with a magnesium anode. Application of scarificial method: protection of buried pipelines, underground cables, marine structures, ship hulls, water tanks, pipes. These are the cathodic protection of a domestic hot water tank using a scarificial anode. These contain steel, magnesium anodes, water outlet and water. Impressed current cathodic protection method: the sufficient direct current is given to underground tank. The negative terminal is connected to tank and the positive terminal is connected to inner anode. When the power supply is on, it converts corroding metal from anode to cathode. Hence, the corrosion can be prevented. This diagram of cathodic protection of an underground tank using impressed currents. This contains rectifiers, tank, current and anode. Application of impressed current method: it is useful for large structures. Applied to open water box, coolers, water tanks, buried water and oil pipelines, condensers, transmission line towers. Next, this is the stray currents resulting from cathodic protections. Next topic is comparison of scarificial anode method with impressed current cathodic method. In scarificial anode method, external power supply is not required. In impressed current method, external power supply is required. In scarificial anode, investment is low. In impressed current, investment is high. In scarificial anode, this requires periodic displacement of scarificial anode. Replacement is not required as anodes are stable. Soil and biological corrosion effects are not considered. Soil and microbiological corrosion effects are taken into account. This is most of economical method, especially when short-term protection is required. This is well situated for large structure and long-term operation. This is a suitable method when the current requirement and the resistivity of the electrolytes are relatively low. This is suitable method even when the current requirement and the resistivity of the electrolytes are high. Next, anodic protection. Anodic protection is a technique to control the corrosion of metal surface by making it the anode of an electrochemical cell and controlling the electrode potential in a zone where the metal is passive. The application of anodic current to the structure decreases the rate of hydrogen evolution. To anodically protect the structure, potentiostat is required. Potentiostat is an electronic device that maintains a metal at a constant potential. The use of potentiostat is to shift corrosion potential into passive potential so that the corrosion of the metal is stopped. The potential range depends upon the relationship between the metal and the environment. Next, application of anodic protection. Applicable in extremely corrosive environments, low current requirements, acid coolers in dilute sulfuric acid plants, storage tank for sulfuric tanks, chromium in contact with hydrofluoric acid. Next, comparison of cathodic protection with anodic protection. In cathodic protection, applicable to all metals. In anodic protection, applicable to only those metals which show active-passive behavior. Used where there is no source of power by employing scarificial anodes. More aggressive corrodants can be handled. In cathodic protection, lower installation cost. In anodic protection, cost is higher. In cathodic protection, standard and well-established method. In anodic protection, feasibility can be predicted in laboratory and the design is easier. Thank you.